Welcome back. So today what we're going to do is finish up what we started yesterday, looking at the general form for the equation of a line. And remember, the general form is just a rearrangement of the one we were looking at earlier, which was the slope-intercept form. Remember, the general form has a number of things that all equations in general form share. That is, they all look like this: ax plus by plus c equals 0, where a, b, and c are just numbers, they're coefficients. Everything is moved to one side. That's why you see 0 on the other side, because we've moved everything to one side. Other attributes are this first coefficient, the coefficient of x, has to be positive, and it can't be a fraction or a decimal. So in other words, it has to be a whole number. And remember, we did rearrange a few equations from slope-intercept form into general form, and we saw how we could make sure that that coefficient of x was positive and a whole number. We're going to do a couple of those today, just to review what we did yesterday. We'll also take a look at the two special cases, the equation of a vertical line and the equation of a horizontal line. And then we'll take a look at a couple of word problems just to see how this equation can be used. Okay? So it should be a fairly short lesson. Anyways, let's take a look at a couple of examples and just rearrange them from slope-intercept form into general form. So, because this one is here, we'll do it. Okay? So y equals negative 2/3 x plus 5. Now remember, what you want to do is you want to rearrange so that everything is on one side of the equation, coefficient of x is positive, and a whole number. Okay? So first of all, let's just rearrange and move everything to one side. And as often is the case, the easiest thing to do is just to move this y over. So get rid of it on the left. That's easy. Remember, we just subtract y from both sides. Y minus y will give us 0. And since this has no like terms to combine it with, we just write it as negative 2/3 x minus y plus 5. Okay? So we've done the first step. We've moved everything to one side. The second step is to specifically deal with fractions. Okay? So we have to have something to get rid of this fraction, and also remember, since the coefficient of x has to be positive, we also have to deal with the negative sign. Lucky us, we can deal with them all at once. And remember, we did this yesterday, you simply take your entire equation and you multiply it by the lowest common denominator. Okay? Now in this case, since there's only one denominator, the lowest common denominator is 3. Since we want also to get rid of the negative sign, we're not going to multiply by positive 3, we're going to multiply everything by negative 3. And you'll see that when we distribute that negative 3 over everything, yes, the 0 too, remember we have to multiply by every single term in our equation. We get negative 3 times 0, well that's 0, that's easy. Negative 3 times negative 2 will give us positive 6 over 3, right? Remember, negative times negative is positive, x. Negative 3 times minus y, again, will give us a plus 3y. And negative 3 times 5 will give us minus 15. Remember, having multiplied through by the least common denominator means this will always simplify to a whole number, in this case to 2. 2x 3y, and minus 15. Okay, we'll do one more before we move on. Okay, why don't we do, let's get rid of this. We'll do another one that has nasty fraction-y bits and negatives and such. We'll do this one. Y equals negative 3 halves x plus 3. So again, step one, move everything to one side. And again, the easiest way to do that is to subtract y from both sides. Y minus y will give us 0. And on the right side, we'll have negative 3 halves x minus y plus 3. Now we have to get rid of the fraction, and we have to get rid of the negative sign. So similar to the last one we did, we're going to multiply through by the least common denominator, and we're going to make it a negative number to get rid of the negative sign. Again, just as an aside, you can multiply an equation by any number you decide to choose. We're going to do a whole bunch of that in the next chapter, in chapter 8. But for now, just remember, it doesn't matter what number you put out here with respect to keeping this an equivalent equation. So long as you multiply by every term, you're good. Okay? So we multiply by all 4 terms, and that gives us negative 2 times 0 is 0. Negative 2 times negative 3 is positive 6 over 2x. Negative 2 times minus y is plus 2y. Negative 2 times positive 3 is minus 6. And then again, this fraction simplifies very nicely into just 3x. And there's our equation in general form. Okay? Easy, easy. Now, we talked right at the end of yesterday's lesson about those special cases. And just to review, we will get there eventually. Okay, so the special case of vertical and horizontal lines. Okay, so for horizontal lines, you will always have an equation that takes the form y equals k. Okay, where k is the y-intercept. Okay. For vertical lines, you will always have an equation that takes the form x equals k, where k is the x-axis. Okay, so just let me find, there we go. So, for example, in this particular one, we have 4x plus 12 equals 0. When we isolate x, so that's your first step, that will give you 4x plus 12 equals 0. Subtract 12 from both sides. 4x equals negative 12. Divide through by 4, right? We're getting rid of that 4 by dividing both sides. X equals negative 3. Once you have your variable isolated, and just a reminder, notice that both of these equations have only one variable, okay? That should set off the little alarm bells in your brain, right? If you see an equation that only has one variable, you're probably going to get either a horizontal, if it's y equals, or a vertical line, if it's x equals. Now in this case, it's x equals. So what is this telling you? This is telling you that this line crosses the x-axis at negative 3. So your line, when you graph it, is going to look like this. Okay? If we were to put this in general form, it would be remember we move everything to one side, it would be x plus 3, right? We've added 3 to both sides, equals 0. Okay? So that's general form. Over here, again, isolate the variable first. We've got negative 3y minus 6 equals 0. Add 6 to both sides to give us negative 3y equals 6. Divide both sides by negative 3. That gives us y equals negative 2. Right? I'll just write that in. So we've added 6 to both sides here. We've divided by negative 3 here. And that's what gives us our final y equals negative 2. Now, just as x equals negative 3 tells you it crosses the x-axis at negative 3, y equals negative 2 tells you this one crosses the y-axis, the vertical axis, right here at negative 2. So, you're going to get a perfectly horizontal line that crosses the y-axis at negative 2. Okay? If we want to put this one in general form, remember we would add 2 to both sides, giving us y plus 2 equals 0. And there's your general form. Okay? Good, good? Okay, let's do some word problems. So, it says this graph shows how the height of oil in a camping lantern changes over time. State the vertical intercept. Now remember, the vertical intercept is another way of saying the y-intercept. It's just where does the line meet up with the y-intercept? And it meets up with the y-intercept right here. Okay? So, the vertical intercept is at y equals 12. Okay? What does it represent? Well, before you can say what it represents, we have to take a look at this and just kind of get an understanding of what's going on, right? So the title here is Height of Oil in a Lantern. The height of the oil at time 0 is 12 centimeters, and then as time progresses from 1 to 2 to 3 hours, the height of oil in the lantern goes down. So what's going on? We got our lantern fired up, it's burning fuel, and as a consequence, you have less and less fuel in the lantern. So what does it represent? Height of oil at the start. Okay, so right before you light the lantern, it's got 12 centimeters of oil in it. State the horizontal intercept, and what does it represent? Well, here's the horizontal intercept right here. X equals 3. What does it represent? Time when lantern is empty. In other words, the time that it runs out of oil or the amount of time that it burns. Okay, there are different ways to describe it. Brooke wants to save $336 to decorate her bedroom. She has 2 part-time jobs. On weekends, she works as a snowboard instructor, earning $12 an hour. On weeknights, she earns $16 per hour, working as a high school tutor. Write an equation to represent the number of hours Brooke needs to work as a snowboard instructor and as a tutor. Okay, so what's the scenario here? She's working at one job, she's getting paid a certain number of dollars per hour. She also works another job, getting a certain number of dollars per hour. Between the 2 jobs, she has to save up $336. So let's just think about this in words, okay? So pay for her snowboarding job plus pay for her tutoring job has to add up to the amount she needs to decorate her bedroom. $336. Okay? let's try and get a little bit more mathy about it. Okay, so S would be her snowboarding job, and for her snowboarding job, she gets $12 an hour. So her pay at her snowboarding job would be $12 an hour multiplied by the number of hours she works, 12S. Okay? Likewise, her pay as a tutor would be her hourly wage, $16 an hour, times the number of hours she works as a tutor. Altogether, that has to add up to the amount she wants to save to decorate her room. Okay, so 12S, $12 an hour times some number of hours, 16T, $16 an hour times some number of hours, altogether has to add up to 336. What is the S-intercept of a graph of the equation, and what does it represent? So, the S-intercept, to find that, we would have to graph our equation. The S-intercept would be the S-intercept would be the total number of hours working as an instructor if she did no tutoring. And the t-intercept would be the opposite. All tutoring no snowboard instructor. How do I know that? Well, just want to make sure I have enough room here. Okay, if this is snowboarding and this is tutoring, then we're going to end up with a graph that kind of looks like this. Okay? Both snowboarding and tutoring have units of hours, right? The number of hours she does for each. At her y-intercept, that would be equivalent to 0 hours of tutoring, maximum hours of snowboarding. Down here would be the opposite. All tutoring hours, but as you can see, my y coordinate is 0 here, so 0 snowboarding. Okay? That one's a little tough. Suppose Brooke works 8 hours as a snowboard instructor. How many hours will she need to work as a tutor? Well, this is where we go back to our equation, and let's see. Yeah, we got room here. So our equation is 12s plus 16t equals 336. Yeah, you can see that. Okay. It's not bad. So it says she works 8 hours as a snowboard instructor. That's this variable right here. Remember we said that was the number of hours she works as a snowboard instructor. So if she works 8 hours, we simply substitute 8 where we see S and simplify our equation. So 12 times 8 plus 16t equals 336. 12 times 8 is 96, plus 16t equals 336. Now remember, to find out how many hours she works as a tutor, what they're really saying is isolate t. So let's do that. We got to get t all alone. We're going to take 96 away from both sides. 96 minus 96 is 0. That'll leave us with 16t. 336 minus 96 is 240. Okay. Finally, to get rid of the 16, we have to divide both sides by 16. 16 divided by 16 is 1, leaving us with t. 240 divided by 16 would be, what, 15? So, how many hours will she need to work as a tutor? 15 hours. Okay? How are we doing? I think we can do some more here. Okay. Let's do number 4. Okay. So, Lana quenches her thirst after a soccer game by drinking a large glass of water at a constant rate. The straight line graph shows how the volume of water in the glass changes over time. So again, take a look at the graph and make some sense of it, right? Our time is our x. Remember, if time is one of your variables, it's always going to be the x. Our volume in milliliters in her glass of water is our y variable, our dependent variable. So she's drinking her glass of water. As time progresses, there's less and less water in the glass. Not a large surprise, right? She's drinking a glass of water, okay? The glass of water starts out how full? Well, that's your y-intercept. She has 600 milliliters of the glass, in the glass at time 0, right before she tips it back and starts drinking. It takes her 12 seconds before the volume of the glass is 0. What does that mean? It took her 12 seconds to drink her glass of water. Okay? So, identify the domain and range in this situation. Well, we'll use interval notation for the domain. And remember, interval notation is nice and easy. It's just your smallest and largest values, which in this case are 0 seconds and 12 seconds. So 0 seconds and 12 seconds. If those values are included in the relation, we use square brackets. Okay? For the range, we'll use set builder notation, squiggly bracket, and may as well use the rate variable. So it's not y, it's actually v, such that we have values for volume that go from 0 milliliters to 600 milliliters. So our smallest is 0, our largest is 600. Our values for volume are between those two numbers, greater than or equal to 0, less than or equal to 600. Since it's a solid line, we can say v is an element of the set of real numbers. Okay, so there's our domain, there's our range. Identify the slope. Well, how do we solve for slope? With our friend the slope formula. Slope equals y2 minus y1 over x2 minus x1. Now, I'm going to pick the two intercepts simply because I'm lazy, and I know that at the intercepts, one of the coordinates is always going to be 0. It's going to make my subtraction a little bit easier, right? So my x-intercept here has an x value of 12 and a y value of 0. My y-intercept up here has an x value of 0 and a y value of 600. Again, notice that at the intercepts, the value of the other variable, so for the y-intercept, it's the x-coordinate, is 0. For the x-intercept, it's the y-coordinate that's 0. We talked about that a couple of days ago. Okay? Now, given that we have a couple of zeros, it makes our subtraction a lot easier. So our y2 minus y1 becomes 600 minus 0. Our x2 minus x1 becomes 0 minus 12, and that gives us 600 over negative 12, or negative 50. So in this case, our slope is negative 50. And what are our units? You have to attach the units to the slope. Well, since it's y over x, it will be milliliters, our y value, over x. Sorry, seconds, our x value. So our units are 50 milliliters per second. Okay? So what does that tell us? That represents the rate of drinking, or the rate at which water in the glass is decreasing. Okay? What is the y-intercept? Well, remember we already talked about that. It's right here. There are the coordinates for the y-intercept. So the y-intercept is 600 milliliters. What does it represent? It represents the full glass before she starts drinking. What is the equation of the line in slope-intercept form? Our friend the slope-intercept form, which is so easy to write if you know the slope and you know the intercept. So we'll put it right here. Remember, slope-intercept form is y equals mx plus b, where m is the slope, b is the y-intercept. We already know those, so we just plug them in. Our slope is negative 50. Our y-intercept is 600. There's our equation in slope-intercept form. Okay? Pretty easy. Okay, let's just finish this up quickly. Rearrange the equation into general form. Let's just go up there. Okay, so in general form, this, remember, is our slope-intercept form. In general form, we have to move everything to one side. All the numbers have to be, or at least the number attached to x has to be a whole number, and the number in front of x has to be positive. Okay? So, take away y from both sides. Remember, we did some examples of this at the very beginning of the lesson. Y minus y is 0, and we get minus 50x minus y plus 600. Last step. Well, this is a whole number. Well, at least it's a non-decimal, non-fractional number. We need to get rid of that negative sign. So since we don't really want to change this number, we only want to change the sign. Whenever we just want to change the sign, we multiply through by 1, and we multiply through by negative 1. Okay? Negative 1 times 0 will give us 0. Negative 1 times negative 50 will do what we want it to, change that to positive 50. Don't forget to multiply this by every term. Negative 1 times minus y will give us plus y. Negative 1 times 600 will give us minus 600. And there you have it in general form. Identify the x-intercept of the line. Well, remember that was, we'll just skim back up there. The x-intercept was right there at 12 seconds. So you could say at x equals 12, or you could give the coordinates and say that it's at 12 and 0. What does it represent? The time it takes to empty the glass. In other words, the time it takes to drink the glass of water. Right, the coordinates of the x and y intercepts, well, we've done that a couple of times already. We've got the x-intercept right there. It's at 12 and 0, and remember the y-intercept was at 0, and whoops, 600. Remember we used those when we found the slope. Okay? So, I hope you feel a little bit better about this. In the next couple of lessons, we will talk about the last rearrangement of the equation of a line. That's called slope-point form, and that is just a rearrangement of the slope formula. Okay? So, I know you can't wait. Try and get a good night's sleep. We'll talk about that in the next lesson. Bye.